Welcome back to the deep dive. We know exactly why you're here today. You're prepping for the GitLab certified Git Associate exam, and you don't have time for fluff. Our mission in this deep dive is simple: a high-impact tactical review of the core Git commands and workflows, the ones the exam is really designed to test. Think of this as your accelerated study session. We're focusing purely on the technical outcomes, the sequencing. We're aiming for command proficiency and fast.
That's exactly right. We're going to synthesize this. It's all about the actionable insights. For every command, we'll focus on its technical consequence. Because for these exams, it's not enough to just know a definition. You have to know what happens next in the workflow.
And what command to use to fix a problem. Right?
Precisely. Or to prevent it in the first place.
Okay, let's unpack the absolute foundation: getting a repository set up on your local machine. When you start any project, you face this fundamental choice that dictates your very first command. You're either starting fresh or you're joining an existing team. And this brings us to that core conceptual difference between git init and git clone.
Right. So if you are standing in an empty folder on your desktop and you're ready to start writing code, you use git init. This command, it just initializes that hidden.git subdirectory right there. It turns your current directory into a local Git repository.
So it starts the tracking process, but it's completely isolated.
It is. It's purely local. It knows nothing about the outside world, nothing about a server.
And this is exactly where the exam often tries to catch you. If the project already exists on a remote server, let's say on GitLab, git init is absolutely the wrong choice.
It is, absolutely. If the code is already hosted remotely, you have to use git clone. The high-value takeaway here, and the key insight for the exam, is that git clone does three things for you automatically. It downloads all the files, the entire history, and it automatically creates and configures the connection to that remote server.
It sets up an alias, specifically?
Yes. It sets up that remote server alias, which is almost always named origin by default on platforms like GitLab. If you used Git init, you'd have to manually add and configure that remote connection later. It's just extra work.
So clone is the shortcut.
It's the shortcut, and it's the correct way to start on an existing project.
Okay, so once we have that repository cloned or initialized, we start changing files. This leads us to the core mechanism of saving work, which is that, infamous two-step process. Git add and git commit. A lot of new learners trip up here because they think Git should work like saving a document in Word.
It really doesn't, and understanding why it doesn't is it's crucial for your success. This two-step process is the heart of Git's control system. When you run git add file, you are not saving permanently. You're taking your changes from the working directory, the actual files you're editing, and moving them into the staging area.
The staging area, or the index. I always think of it like a shopping cart right before you check out.
Yeah.
You're confirming exactly what you want to buy.
That's a great analogy. The staging area lets you curate a perfect snapshot of what you want to save. You might have 10 files changed, but maybe only 5 of those changes are logically related.
So you just add those 5.
Exactly. You add just the 5.
And what happens if you run git commit without running git add first?
Well, nothing relevant gets saved. The git commit command is the final step. It takes everything that's sitting in that staging area, wraps it up with your commit message, and then permanently saves that snapshot into the local repository history. So if you see a multiple choice question on the exam asking how to save changes permanently, the answer has to include both git add and git commit.
That distinction, working directory, staging area, local repository, is just fundamental.
Yeah.
Okay, now let's shift gears. Our changes are committed locally, but they need to be shared. We need to bridge our local machine with that remote server, which brings us to the sync commands, git push and git pull.
Right. This is all about collaboration. As developers, we're constantly synchronizing. So if you've just committed new work locally and you want to share it and get it backed up on GitLab, you execute push, you're sending your committed history up to the remote repository, to origin.
And the opposite. If I step away for lunch and my colleague pushes up a huge new feature while I'm gone, I need to get their updates.
Then you run git pull. If push sends your changes up, pull brings remote changes down. And here's a technical point that's really important for the exam. Git pull is a convenience command. It's actually 2 steps in one.
Okay.
First, it fetches the remote content, and second, it automatically tries to merge that content into your current local branch.
So pull is integrating remote changes immediately into my work. That sounds convenient, but maybe a little risky sometimes.
It can be.
We'll dive into that risk a bit later when we talk about fetch, but first, let's look at why we developed this way in the first place. Branching.
Branching is I mean, it's arguably the most powerful feature of Git, and it's the foundation of the standard GitLab flow. We
Yeah.
use Git branch to create a new, isolated stream of work.
Why? To keep main stable, right.
Exactly, to maintain the stability of that primary branch. If you're building a new feature or fixing a bug, you create a branch to separate that work from the stable code base.
So we run git branch, new feature name, the branch is created, but we're not using it yet. We're still on the original branch.
Correct. You still have to navigate to it. For navigation, the traditional command is git checkout branch name. It still works perfectly fine. However, for the exam review, you really should recognize the more modern approach. Git introduced git switch specifically for moving between branches.
And this is a great update because checkout was kind of overloaded, wasn't it?
It was, exactly. Git checkout was also used for restoring or discarding files, which caused a lot of confusion. Git switch is just cleaner for navigation.
So there's a different command now for file changes.
Yes. There's git restore for handling file reversions. So if the exam asks you to switch branches, either checkout or switch would work, but switch really shows, the modern, clearer command.
Right. And eventually that parallel work is finished, reviewed, and it's ready to be absorbed back into the main code base. That's where git merge comes in.
When you run git merge source branch while you're on your target branch, Git tries to combine those separate histories. The most common outcome is a new commit, a merge commit, that just stitches the two histories together. But here's a nuance the exam might test. Sometimes the history is completely linear. Your target branch hasn't changed since the source branch was created.
Okay.
In that case, Git does what's called a fast-forward merge. It avoids creating an extra merge commit and just moves the pointer forward. It's a detail, but it shows you really command the material.
Managing complex projects means being prepared for when things, inevitably go wrong or when you just lose your place.
Yeah.
You need visibility. So let's talk about the safety commands, your troubleshooting toolkit.
First and foremost is Git status. I call this the developer's GPS.
I like that.
Git status tells you at a glance the state of the entire ecosystem. It confirms which branch you're on, which files are tracked, which are untracked, what changes are sitting in the working directory, and what's ready in the staging area. If you don't know what to do next, just run Git status.
Okay, and once we see the state, sometimes we need to understand the past. We need to review why a file is the way it is.
That's Git log. Git log is your time machine. It shows you the history of permanent changes in your local repository. You'll see the unique commit hash, the author, the date, the commit message. If an exam question asks you to find the hash of a previous commit, Git log is how you do it.
And for the fine details.
For being surgical about it, you use Git diff. Git diff is essential for showing granular line-by-line differences between any two states. You can get diff to see what's changed between your working directory and staging, or between two commits, or even two branches.
It answers the question, what exactly did I change?
It does, very precisely.
Now we get to the nuance that, in my experience, often separates a passing score from a stellar one. These next concepts require understanding what Git is doing behind the scenes. So let's revisit that distinction between fetching and pulling, and then explore temporary storage with git stash.
This is the distinction between looking and leaping. We said before that git pull is fetch plus merge. The alternative is to just run git fetch. When you run git fetch, Git contacts the remote server and it downloads all the new data, all the commits, all the files.
But the key point is what it doesn't do.
Correct. It downloads the data, but it does not touch your local working branch. It stores those remote changes in what we call remote tracking branches, like origin main.
So the changes are on my machine, but my code is totally unaffected. I can look at them safely.
Exactly, you can inspect them.
So why would a developer choose that manual two-step approach over the convenience of pull?
Conflict avoidance and review. If you suspect your colleagues have made changes that might conflict heavily with your local work, you use git fetch first. You can then review their branch safely. You only commit to merging when you're ready to handle potential conflicts, rather than being forced into it by a git pull.
Excellent. Okay, the other advanced concept is managing context. We've all been there. You're deep in some messy, unfinished feature, but a high-priority bug report comes in. You need to jump to the main branch immediately to fix it. Your code is dirty. It's not ready for a terminate commit.
This is the perfect use case for git stash. Git stash is Git's temporary shelf. It takes all your uncommitted changes, both staged and unstaged, packages them up, and temporarily removes them from your working directory. It restores your current branch to a pristine, clean state.
Which lets you switch branches instantly.
Instantly. You can handle the hotfix, then come back later.
It's like the technical equivalent of hitting a pause button on your work.
Exactly. It saves your place. You can do the hotfix, commit it, push it, then jump back to your feature branch, use git stash pop or apply, and resume exactly where you left off.
Knowing Git stash is a huge asset on the exam. It shows, workflow management.
It really does.
Now, let's tie all this directly into exam strategy. The GitLab Certified Git Associate exam isn't just about isolated commands. It tests your knowledge of the platform's required workflow, the GitLab flow. Can you just outline that mandatory sequence required to submit code for review?
Yes, this sequence is critical. Because protected branches are standard in any professional setting, you never ever commit directly to main. The goal is always to create a merge request, an MR, and that requires a very specific sequence of Git commands. Step 1. You start with separation, git branch feature name. You must create a new feature branch. Step 2. You work locally and save git add, followed by git commit, my changes. This saves the changes to your local branch history. And step 3. You synchronize and initiate the review. You run git push u origin feature name.
And that push is the action that triggers the platform automation, correct?
Yes. In a standard GitLab environment, pushing a new branch to the remote server is what triggers the option to create a merge request. The MR is the platform mechanism for peer review and quality gates. The exam is testing that you understand that order. Branching must precede committing, and committing must precede pushing.
Fantastic. That whole sequence is the practical application of everything we've reviewed. We've covered initializing a repo, saving changes with the staging area, bridging local and remote work, managing parallel development with branches, troubleshooting, and clarifying those advanced nuances like fetching and stashing. So for a final thought, let's connect this technical framework back to platform policy, specifically protecting the main branch. We just detail the required sequence: branch, commit, push, then merge request. Given that developers use platform settings to prevent direct commits to main, consider this. What happens if a team member tries to bypass this and use a destructive command like git push force to push unreviewed code directly into that protected main branch? How does the technical framework of Git, specifically the integrity of the commit history and the server configuration support, or reject the policy expectations of GitLab? How does it ensure that an accidental disaster is technically prevented, not just conceptually discouraged?
Understanding those technical constraints is key to truly mastering Git. Apply the outcomes we discussed today, especially that workflow sequence, and you'll be ready for the exam. And more importantly, you'll be ready to collaborate effectively in any Git environment. Good luck with your review.